not that much to do. So you need a calculator. Those of you in the classroom, we are going to have a piece of paper to write on, so you don't need to do the documents.
Oh, awesome. Thank you.
Brothers. All right. Oh, heck. I gotta go back through. So I'm going to get us rolling on this. And then those of you at home, I'm going to, once I get their candy distributed, hang out with me and I'll give you numbers that you're going to work with. Okay. So this is the lab. It's really straightforward. It's just thought throwing in some candy would make it more fun, of course. This was originally written by somebody else for M&Ms. I added in the Skittles part. M&Ms actually come in different percent in the bags. They're on purpose, have different percentages. The highest percentage is brown and the other ones are less. The Skittles, on the other hand, are supposedly equal. All of the colors are supposed to be equally represented. So if you have 5 colors, 5 flavors, divided by into 100, you get 20% is the expected distribution for those colors. So that's what we're working with today. So the lab's set up so we can use either M&Ms or Skittles. So we don't have any blue Skittles in the standard color bag. So there's one extra line. It's not that big a deal. The first part's really simple. It says team, but I'm going to give each of you your own cup of Skittles, most of a cup of Skittles, little Dixie cup. And then you're going to go and take those little foldy paper towels are there. You can use those. Pour out your Skittles and count up each color. Okay. And then you're going to do the percent composition. So you just take, once you get the total of all the Skittles that are in your cup, take however many, 9, 10, 12, 14, whatever it is, red divided by 50 or 60 or whatever you get. Okay. And then multiply by 100 to get percent. While you're working on that, I will, we'll talk about doing percent error. Some of you are going to get to that early. Percent error is just calculated by taking the absolute value between what we expect, 20.00. And yes, I want you to go to the hundredths place, please. So all of the expected percent, this is the second data table. The expected manufacturer value is 20% for each color. I can just about 99.99999% guarantee that you will not get 20%. One person today has gotten that for one color. Okay. So I will tell you that. So we'll see if that happens in here. And you can't eat them to make the percent work out. That's cheating. All right. So percent error, you take the accepted manufacturer's value in this case, minus your experimental. That's going to be the number, God bless you, that you get up here. Whatever your percents are up in part 4, that's going to be the second column. And once you have that difference, you divide by the 20 again, and then times that whole thing by 100. And I'll go through that with you if it doesn't make any sense. Towards the end, we're going to pool our data, and I'm going to call your name and ask you to give me all 5 colors, the counts that you got, and then we'll get a class total and see how that works out. One other thing we realized earlier today, this extension should be 7, not 6. I have 2 6s on there. If it bothers you, add another I on the extension. It's not that big of a deal, but just a heads up. All right, so super simple. Those of you at home, hang out. I'll be back. Those of you here, everybody gets their own cup. Actually, I think you can go ahead and sign out of the meet if you're in, because you're going to have a hard copy, and you are not going to need others. All right, so just start with Aiden's row, and then everybody just keep filling in behind him. I'm going to pass out the cups of Come on down. Let's go. Getting ready in line, peeps. Grab a paper towel if you want. You can get some of that too, but these are easier. They're the free cuts, if you will. You're welcome. Next row, let's go. Once you get them counted, yes, you can start eating them. No need to wait. I'm not going to torture you. Everybody wants a lot.
Yeah.
Oh, heck and darn.
That's a strong language here.
I know. You're gonna lock me up. Oh, please. Oh, it's fine.
You're gonna get a column by this.
And last one, please. All right.
Oh, I didn't get it. There would be a bad time to get colorblind.
You can probably discern the colors anyway. All right. So you can actually, if you, well, that's fine. You're doing it individually. You guys are so good. So peeps at home, here's my count for you. 6, 8, 12 for red. 2, 4, 6, 8 for orange. Yeah, Skittles have a lot of deformities. Have you guys noticed that? 6, 8 for purple. 7 for apple. 6, 8, 10 for lemon. 28, 35, 45. Boom, boom. Hundredths place. Oh, helps to turn it on.
What do you got this year? Crazy.
Yeah, 49.
Perfectly 50.
I got 47.
Perfectly 50? Wow, that makes it easy. Okay, so peeps at home, these are the numbers 12, 8, 8, 7, and 10. Give us 45. And so you're just doing percents. So 26.67 goes here. And then to do percent error. And that, divide that whole thing by 20. And then times that answer. By 100. So do set it up. Show me your setup. You don't have to do long division or multiplication, but show it set up, just like I typed mine on here. And then percent error is a tricky one. Normally we want to know how good we're doing, not how bad we're doing. Scientists are, I don't know, negative, I guess. So if all of them are supposed to be 20% and you got 26.67, to do percent error, you take the absolute value of the accepted minus your experimental. So that's going to be 6.67 divided by the accepted, and then times that whole thing by 100. So 6.67 different from 20 doesn't sound that bad until you realize that's actually 33% error. Okay, so 33.35% error. That means you're 66.65% right. Normally we look at test scores and stuff as, you know, the number you got correct out of the total. But when we look at data analysis, we look at how wrong you are. It's really sad.
Can I unstaple these and staple again?
Of course. Okay, any questions from home? Oh, Isabel's here now. Okay.
You have to do access value.
Ada, it says you're supposed to read already. Are you supposed to go to baseball? At 11:25?
No, I'm not supposed to meet at the bus stop too.
She must have just got you in the wrong group somehow.
Did you give something else to early?
Well, no, because I think that the afternoon is like at 4. And it's only very hard.
These games are so cool.
Well, yes, there's checklists.
Oh, okay. That's what I thought. Yeah, I forgot that.
So once you get to part 6, you just wait.
Yeah, get all your percent errors done. And I'm going to ask for your numbers to get you the class totals. So I'm just going to go with the seating chart. So Logan, just read me. It's down on yours. I'm going to write them across. Go ahead. How many red, orange, grape? Your individual, your cup of Skittles. Yeah.
Absolute value.
You just took over the absolute value.
Guys, I count you here. I'm in the front row. 9, what?
8,
Yep.
12,
Thank you. Chuck, Burt Whistle.
11,
Mhm.
8,
Mhm.
13, 13, and 8.
Perfect. And Jillian?
11,
Uh-huh.
9,
Uh-huh.
9,
Uh-huh.
13,
Uh-huh.
and 10.
Perfect. And Michael?
Got 13, 11, 13 again, 9,
Is that a 10?
7.
7. And Gabby?
12, 10, 5, 9, and 11.
Perfect. Taylor?
12, 7, 15, 7, 10.
I'm sorry, what was the last one?
10.
And Jack Conte.
10, 8,
Sorry.
9, 13.
Gwen?
14, 5, 9, 9, 13.
Perfect. Bethany?
10, 9, 4, 12, 11.
Oh, you got duped on the great ones, huh? Guys,
10, 10, 8, 8, 6.
beautiful, Lauren.
11, 5, 9, 12, 6.
Good job, Colin.
13, 14, 6, 5, 13.
Wow, you got a lot. Haley.
11, 7, 8, 13, 10.
Beautiful, Aiden.
11, 5, 10, 9, and 8.
Hey, Galileo.
8, 11, 12, 8, 8.
Beautiful. Last but not least, Amani.
13, 12, 6, 8, 7.
Beautiful. Okay, so let's get this going on.
Actual value in virtual
8, 15, 9, 39, 42, 52, 4, 72. Okay, 175 for red.
So it wasn't exactly
So it's okay if I get
yeah.
9.
That's for value.
This is
I don't know.
She's on.
That's what he's
One.
I don't know, just
It might be a value for a different.
value.
Or is that what the correct?
here's a 4, this one.
I did that.
Just take 20 and then split it.
No, it didn't. I don't want to.
She's asking for you to put like the.
I thought
got
a really
correct
good
and
one.
Why would the person?
Like my small ones are really big. So my big one is most.
I got 0%, 28%, 20%, 30%. This is very even.
Let's see what helpful and
Yeah. The decibel one?
I don't think I.
Are you about a 20? Again, yeah.
Right, so the class totals go here. 175, 143, 145, 156, 150. I'm doing something. Thank you. Question.
We're finding like the 33 and the 66 for ours.
The 33 and the 66.
For
No,
your example, you found 32.
you're just finding percent error. You're not going to get a negative because it's absolute value. All right, nice round number, 769. Boom. So to do the percent composition for the class data, you're going to take the class total and divide it by the class total. So for example, 22.7 6. So when we pool everybody's strawberry Skittles together, we got 22.76%. That's closer to 20% than my little cup. Okay. So, and that's what we expect. We expect to get closer and closer the more and more data points we have, which is exactly how scientists work. We try and have as many bits of information as we can because we're hopefully likely to get closer to the truth. Now, we don't know what the values are supposed to be like we do on this exercise. This is just a fun thing to do on a Friday. But, you know, the more you do it, the more you get data, the more evidence you have, and the more likely you are to get closer to the true number. So since the reds are higher than expected, then you probably expect that the other colors will be lower than the 20%. Let's see what green is just for the heck of it.
Orange and brown, they're really similar. They both around 18.86.
86 what? Hundredths place.
Yeah.
86 is to the 10th. Oh, say it one more. 20.86?
18.86.
18.86. Great. That is great. So the green apple got 20.286. That's 9. So, and that's fine if they round to the hundredths place to the same. I totally can see how that would happen. Okay. Now, I'm not asking you to do percent error on this, but I just want you to understand 2.76% doesn't sound that bad. Okay. Oh, we're only off by 2.76. Well, that's not really the truth. So if we did 769 times 20%, okay, it should be different, right? So how much is 2.76% off? It's a bit. So you expect 20, and you don't have to do this. I'm doing percent error again, just to show you that even though the number doesn't sound like it's a big deal, it's close to 10% error, and that's not good. Oops, divide by 20. It's actually 13.8% error. That's really bad. It's not as bad as the other. Okay. You didn't get 47 for this one. For what I'm doing.
Oh.
I thought you were talking about what I was doing.
No.
Okay, so even though, you know, we didn't get 20% as a class, we get 22.76. That's better. Okay, but it's still a lot of error. So when you go to college chem days, at least that's how they used to do it, and Davis, 0 to 2% is considered perfect. That's within the realm of what they call experimental uncertainty. Above 2 up to 5% is okay. They might take off a point or two. More than 5% up to 10% is bad, and they'll take off more points. And if you got something more than 10% error, you're in trouble. Okay, they'll probably make you do it again. So I'm just, lots of the stuff that you do, there's a known value. You're not trying to find out something that's not been ever recognized before when you're doing labs in college. So, you know, if you're within 2%, good on you. Okay, now you had no control over this. I'm not going to take any points off of you. Okay, that's not the point. I just want to let you know that this percent error thing will come up again if you take more science classes. And it's irritating as heck if it doesn't come out right. So I just wanted to, as a class, you know, it's better, but it's still a good percent error. It's kind of high. All right, so that is really all we need to do for today. Those of you that still need to finish up the Explore Learning thing can switch to that. Those of you at home, have a nice weekend. Unless you have questions, I'm happy to answer and I can help you. Everybody else can sign out.